Hello and welcome to the second part of Lesson 2, Evaluating Expressions in Unit 0 in our Grade 10 Academic Math class. We started by looking over BEDMAS, which is the set of rules that govern the order of operations we perform when evaluating expressions. We worked through some expressions that needed to be evaluated here, and in the second part we're going to look at evaluating algebraic expressions. Now that sounds fancy. It really just means we're going to have expressions that have some letters in them as well, and those will need to be dealt with by either simplifying them or substituting in a known value for those variables. Let's look at the first example. We have 3x all being cubed plus 2y all being squared, and the values we will be assigning x and y are -1 and -4 respectively. We're going to start, because there's no simplifying that can be done here, we are going to start by substituting in directly. So in the place of every x, let me grab a highlighter here, so in the place of every x, I'm going to be putting in a -1, which I did here, and in the place of every y, I will be putting in a -4, which I did here. At this point, we are going to simply evaluate as we did before. We'll deal with the brackets first. So 3 times -1 gives us -3. Let's change up our color there. That's going to give us -3. That cubed is still hanging around. We're going to add that to, in this case, 2 times -4, which is going to give us -8. That's brackets. Next step, we have some exponents to deal with. So -3 cubed is going to give us -27. And -8 squared is going to give us +64. Last step, no multiplication and division in this one. We're going to just be combining these with addition or subtraction. In this case, we're adding them, and -27 plus 64 is going to give us 37. So that's what we want to be doing. We want to be doing a substitution step, and then just continue evaluating as before, following BEDMAS. Let's look at our second example. So we have 6x plus 5/6 y. And the values we'll be substituting in are for x 2/3 and for y -3/4. So this is going to get us some fractions. Not a big deal as long as we remember how to deal with fractions. So there's no simplifying that can be done there, so let's just start by doing some substitutions. Now for the sake of simplicity, I'm going to write 6 as 6/1, knowing that what I'm substituting in for x will be 2/3. Now the 5/6 y fortunately already has it's already written as a fraction, and we are going to be substituting. And I'm just going to assign that negative to the numerator. It doesn't really matter which one you assign it to, but leaving it in the middle is kind of weird. So I've assigned it to the numerator. So first step, substitution, complete. Now we are going to be doing the multiplying of the first term. Because remember, what we've got here is we've got two things being multiplied together, added to two other things being multiplied together. Now, before we do this multiplication, I'm going to insist that you do some reducing. So in order to reduce, I recognize that there are parts of in the first term, there's parts of the numerator and denominator that can be reduced. For example, I recognize that you can divide both 3 and 6 evenly. So 3 divides into itself once, and 3 divides into 6 twice. Now that's all the reducing that we can do in our first term. So let's go on to multiply the numerators by the numerator, or the numerator by the numerator. So that's 2. Right there, 2 times 2, that's going to give us 4, and 1 times 1 is going to give us 1. So there's our first term worked through. Let's try to apply that same thinking to the second term that we have. So we have 5/6 times -3/4. Let's see if we can do some reducing here. And again, I see some opportunities for this. I recognize that I can divide both -3 and 6, -3 and 6 by 3. -3 divided by 3 gives us -1, and 6 divided by 3 gives us 2. Again, there's no further reducing that we can do here, so let's move on to the next line and simplify this by doing numerator times numerator. So 5 times -1 is -5, and in our denominator 2 times 4, which gives us 8. So in our last step here, we need to come up with there's only adding and subtracting left, adding in this case, so we need to come up with a common denominator. In order for us to do that, we need to find a common denominator. We have denominators of 1 and 8 happening, so I'm just going to multiply both numerator and denominator here by 8, just to get the same common denominator. 8 4s are 32/8 plus -5 over 8. So again, I'm not going to write this, well, you know, I'll write it out. We got the space, we got the time. We have two signs banging up here. We have a plus and a negative. So a positive and a negative, when mashed up together, we're going to replace that with a single sign. That will be a negative. So we have 32/8 minus 5/8. That's going to give us 27/8. The answer cannot be reduced, and here's where we're going to leave it, 27/8. Hopefully this is making sense. Again, you want to be writing these out in your notes in their entirety, including all the symbols and steps that I'm kind of showing you. These are your reference when you move to the homework, because obviously I won't be around to talk you through them directly anyway. So having these sort of thorough written out solutions for your notes is very important, and I stress its importance often, and I absolutely believe it. So make good copies of this for your notes for sure. All right, last one, here we go. This one we're bringing up the level of complexity. We've got 2x over 6y minus 4x over 2y, where we're going to substitute -1/4 in for x, and we're going to substitute 2/3 in for y. So this is going to create sort of multiple levels of fractions. It can be a little bit complicated, but I think we've got this under control. So we're going to start with that substitution step. I've already written it in because I was feeling lazy. So we have 2 times -1 over 4, all over 6 times 2 over 3, and then minus second fraction, 4 times -1 over 4, and 2 times 2 over 3. So we are going to now do this multiplication if we can. So as I look at this, though, I realize that as before, I would not just write that as a 2. I'm going to write that as a 2 over 1, and I'm going to write that not just as a 6, but a 6 over 1. Visually, I think this is a little bit easier to see. Let's do a little bit of reducing here if possible, and it is possible. In fact, if I'm looking at this first set of multiplication, the numerator of the first fraction, I can divide both one term in the numerator and one term in the denominator by 2. So 2 divides into itself once, and 2 divides into 4 twice. And that's all the reducing that I can do there. Let's have a look at the denominator of our first fraction. Let's see if we can do some reducing, and I see that we can. So I can divide both the 3 and the 6 by 3. 3 divided by 3 gives us 1, and 6 divided by 3 gives us 2. So let's have a look at the result of this first set of multiplication, or reducing and then multiplication. So in our numerator here, we have 1 times 1, which gives us 1. And in the denominator, we have 1 times 2, which is going to give us 2, and that's all over. And here we have 2 times 2, which is going to give us 4. And we have 1 times 1, which gives us 1. So we have 1 over 2 all over 4 over 1. So that is our first fraction. Let's go have a look at the second one. Subtract. And again, I'm going to do that rewrite again. I think that makes it just a little bit easier for us to sort of see visually what's going on. That was a 4, I believe. Yep, 4. So we have 4 over 1. And we have 2 over 1, I think. Yep, perfect. So let's see if there's any reducing we can do. Again, in the numerator of our second fraction, I see that there is some reducing we can do. There is a term in both the numerator and the denominator that is divisible by 4. 4 divides into itself once and once, so that's all that we can do there. Let's have a look at our denominator. And unfortunately for our denominator, there isn't any reducing that we can do. There are no coefficients, no numbers, that are equally divisible by a factor in the numerators and the denominators. So we're going to leave this one alone. Let's write out that next step then. So our numerator is going to be 1 times 1, or sorry, 1 times -1, I guess. So that'll give us -1. Oops, let's change up our colors here. That's going to be -1 over 1 times 1, which is going to be 1, all over. And here we have numerator times numerator, which is going to be 4, over denominator times denominator, which is going to give us 3. So there you have it, 1/2 over 4 over 1, minus -1 over 1, all over 4 over 3. So how do we go about dealing with this? According to BEDMAS, this is division, and this is division. So we need to complete that before we do our subtraction. So in order to do that, I'm going to write this out in a slightly different way. I'm going to write out 1 over 2 divided by 4 over 1. and I'm going to bracket that just so I remember it needs to be done first, minus negative 1 over 1 divided by 4 over 3. So just rewriting it in a slightly different way. Now hopefully I can see that I can apply KCI to both of these. I have keep, change, invert, and I have keep, change, invert. In order to do that, I am going to rewrite as 1/2 times 1 over 4, subtracting negative 1 over 1 times 3 over 4. So I've done the keeping, the changing, and the inverting. And now I have some multiplication again. There is no reducing to be done here. We have 1 over 2 times 1 over 4. So let's just do that. Numerator times numerator, denominator times denominator. And in our second term, again, no reducing to be done. So numerator times numerator, denominator times denominator. And there we have it. Now, this very last step, we have subtraction left, but first things I'd like to do is have a look at that. I know that ultimately I'm going to end up with a plus in here, and I also need to come up with a common denominator. And what I see is that between 8 and 4, 8 is a common denominator, so I'm going to multiply both the numerator and the denominator of the second fraction by 2 to get that common denominator. So here we have it, 1/8 plus, and 3 times 2 is 6, and 4 times 2 is 8. And now we add these two together, add the numerator, keep the denominator. Whew! And we made it. Grand finale, doing amazing. Now this very last one right here, this is pretty straightforward. We're running a little long on this video, but I'm going to squeeze it out anyway. This is a word problem. It says the surface area of a pyramid can be found with the formula surface area equals 2sb plus b squared, where b is the length of the base and s is the slant height. Find the surface area of a pyramid with a base length of 3 and a slant height of 2.1. So for us, we are going to be just doing direct substitution here. So there's our equation. In the place of the slant height, we're going to put in 2.1, and the base, I believe, was 3. Yes, it was 3. So there's 3 plus base was, again, 3 squared. So let's work our way through this. We have here, and I'll just do this multiplication in my head sort of in a linear fashion as I go along. So that's going to be 4.2 times 3 plus 9. And 4.2 times 3, that's going to be 12.6 plus 9. And 9 added to that will give us 21.6. And I believe the unit of measure for our surface area will be in centimeters, but because it's an area, it will be centimeters squared. And as with word problems, we always need to have a little therefore statement. So therefore, the surface area is 21.6 centimeters squared. Now I know I moved through that one fairly quickly, but again, I'm substituting in values that I know. The question itself told you what b and s were equal to, and then it went on to provide you with a base length and a slant height. So there you go. On purpose, we make these numbers straightforward enough that you can multiply them without a calculator, which, as it says here at the start of the homework, you need to do. And that's it. So you can head off now to work on the homework. If you have any questions, obviously, as always, email me, let me know. I can either make a video or I can provide you with some email support. Otherwise, good luck, and we'll see you in lesson number 3.